In this class, we are going to focus on pressure and its measurement. So before going to the pressure measurement by using manometers, so first what do we see, we are going to look the pressure and types of pressure. After that, we are going to see the pressure measurement by using manometers. So in simple word, pressure is nothing but force per unit area. So pressure of fluid can express the magnitude of normal force per unit area applied on surface. The units of the pressure will be Newton per meter square. Pressure is nothing but force per unit area applied on surface. The units will be Newton per meter square. So we are going to see the types of pressure in this diagram or line diagram. So here we have the pressure of the fluid. The pressure of the fluid will be measuring on two different systems. One is the so here we have two systems. The pressure of a fluid is measured in two different systems. So in one system it is measured about the absolute zero or complete vacuum, absolute zero or complete vacuum pressure. Another one will be the above the atmospheric pressure. Above the atmospheric pressure we call it as a gauge pressure. So one system is the above the atmospheric pressure, that is about gauge pressure. The first one is the above the absolute or zero vacuum, perfect vacuum, that we call it as a absolute pressure. So the relation of the absolute pressure is equal to atmospheric pressure plus gauge pressure. The relation of the pressure, absolute pressure is equal to atmospheric pressure, absolute pressure is equal to atmospheric pressure plus absolute gauge pressure. Absolute pressure is not equal to atmospheric pressure plus gauge pressure. Then coming to the vacuum pressure is equal to atmospheric pressure minus absolute pressure. So this is about vacuum pressure. This is about a vacuum pressure. Vacuum pressure is nothing but atmospheric pressure minus absolute pressure. We are coming to the absolute pressure, nothing but atmospheric pressure plus gauge pressure. So this is the relation between the pressures. So this is about a gauge pressure and vacuum pressure. Vacuum pressure is nothing but atmospheric pressure minus absolute pressure. So now we are going to see the pressure measurement by using manometers and mechanical gauges. So these are the different types of pressure measuring devices. So measurement of pressure by using manometers and mechanical gauges. So now in this class we are not focusing on mechanical gauges. We are mainly focusing on manometers. So pressure measurement by using manometers. So here in this manometers, the pressure is measuring devices which are based on the principle of balancing the column. So you can underline this, balancing the liquid columns. So the pressure is to be measured based on the principle of balancing of the column of liquid by the same or another column of liquid. So here in the manometers are the pressure measuring devices which are based on the principle of balancing the column of liquid by the same or another column. The manometers are classified. So here we have a classification of the manometers. So the classification of the manometer will be simple manometers and differential manometers. So the simple manometers further classified into piezometer, U-tube manometer, and single column manometer. So the single column further classified into vertical single column and inclined single column manometers. Then we have, so the differentiate pressure is to be measured by using differential manometers, in that U-tube differential manometer and inverted U-tube differential manometer. So now we are going to see the piezometer in the simple manometers, that is about piezometer and U-tube manometers. Then after that we are going to see the differential manometers. So these are the pressure measurement by using manometers. The manometers will be the simple manometers and differential manometers. So then second measuring instruments or pressure measuring instruments that is about mechanical gauges. So like a bellow gauges, board and tube pressure measurement gauges, mechanical gauges are there. So now in this class we are focusing on only manometers. So this is about the simplest manometer, that is about physiometer. So physiometer is the simplest form of manometer. It measures the gauge pressure only. It measures the gauge pressure only. So it measures the gauge pressure only. Physiometer for measuring the gauge pressure only. So here, so this is the pressure where the pressure is to be measured. One end will be connected where the pressure is to be measured, and another end of the physiometer will be open to the atmosphere. One end will be connected to where the pressure is to be measured. This point where the point where the pressure is to be measured. Another end of this manometer will be open to the atmosphere. So in the pressure at any point in the liquid is indicated by the height of the liquid. In the pressure at any point in the liquid is indicated by the height of the liquid in the tube above that point, which can read in the calibrated scale. So here we have a scale. So the pressure at point A, is given by P equal to rho GH. Rho GH. Rho, that is about the density of the water, is the gravitational, and H is nothing but the fluid or liquid rises. The liquid rises. This is about height. So that pressure of the point P equal to rho GH. So one end will be connected to the where the pressure is to be measured, and another end will be connected to open to the atmosphere. So the pressure at point is given by P equal to rho GH, or weight of the fluid. Rho GH is nothing but weight of the fluid. So that is about piezometric height. So advantage of this piezometer, it measures the gauge pressure only. So it will be easy technique, accurate and economical. So the disadvantage will be, so it can't measure negative pressure as well as gases pressure, that is pressure of gases. So this is about the physiometer. This is the simplest form of manometer, measuring only gauge pressure. Now coming to the next one is the U-tube manometer. So this is the overcome the limitations of the physiometer. This is the U-tube manometers. These are the U-tube manometers where the pressure is to be measured, and another end will be similar to the physiometer. Another end will be connected to the atmosphere. So this is about U-tube manometers. These are limitations to overcome the limitations of the physiometer. So now we'll see the physiometers. So these are the U-tube manometers. So you can observe in this diagram. So U-tube manometer. So this where the pressure is to be measured, one end will be connected to the where the pressure is to be measured in that vessel or space. Another end will be connected to the atmospheric pressure. But you can observe in this diagram the specific gravity or density of the fluid will be different in the left limb and right limb. So so here U-tube manometer, so it consists of a glass tube bent in shape U shape. So this is about U shape. So one end which is connected to the A point, that is about which pressure is to be measured. Another end is remains to opens to the atmospheric. So the tube generally contains mercury. The tube generally contains mercury or any other liquid whose specific gravity is greater than the specific gravity of the liquid, whose pressure is to be measured. So you can observe in this U-tube columns the specific gravity of the fluid, specific gravity of the liquid is greater than the specific gravity of the liquid which is to be measured in this vessel, right? So it contains The tube generally contains mercury or other liquid whose specific gravity is greater than the specific gravity of liquid whose pressure is to be measured. Now observing this figure, so this is about we have a datum line xx. This is about datum line. This is about datum line. After that, so let the point, this point which is pressure is to be measured, this point A, let B is the point at which pressure is to be measured, whose value is P. The datum line is AA. Right? The datum line is XX. The datum line is XX. So this H1 is the height of the liquid above the datum line. So this is about our H1. So here the point where the pressure is to be measured. So this H1 above the datum line. H1 is so this is my datum line XX. H1 is height of liquid above the datum line. So similarly H2. So this is about right limb. So this is about H1 is about left limb. H2 is height of heavy liquid above the datum line. Then similarly ρ1 density of the liquid and ρ2 is the density of heavy liquid. So now we are going to measure the pressure P equal to rho GH. So first one P, this where the pressure is to be measured at point A. So that P plus, so you can observe here, P plus rho G H1 above the datum line, this height above the datum line. Then equating then right limb rho 2 G H2. So now equating these two pressures, P plus rho 1 G H1 equal to P2 G H2. So now P equal to P2 G H2 minus P1 G H1. So this is about where the pressure is to be measured here. The point P where the pressure is measured here. So that equating right limb and left limb, balancing the columns, then finally we'll get P equal to P2 G H2 minus P1 G H1. So in this way we are going to measure by using U-tube manometers. For measuring the vacuum pressure, you may observe this diagram. The left limb, the level of the heavy liquid in the manometer will be showing like this. So this is my datum line. You may observe for measuring the vacuum pressure. So the level of the heavy liquid in the manometer will will be shown like this. So pressure, so this is my datum line A. This is my datum line A. So pressure above the datum line in the left column. So that equal to, so the heavy liquid P2 rho G. So in the left limb that will be rho 2 G H2 rho 2 G H2 plus rho 1 G H1 plus P where the pressure is to be measured. So here we are measuring the vacuum pressure. So the heavy liquid you may observe in this diagram in the left limb. So entire will be in the left limb only. The datum line pressure above the datum line in the left column, that equal to P2 rho G H2 plus rho G H1 plus P. So similarly pressure head in the right column above the datum line, that equal to 0. So in the right limb, in the right column, pressure head in the right column above datum line is nothing but 0. So now equating these two, left limb and balancing the left limb and right limb, finally we'll get, so that equal to 0. Finally we'll get P equal to, this P equal to rho 2 GH2 plus rho GH1. So this is about negative pressure. For measuring this vacuum pressure, we are using this type of manometers. So this is about simple manometers. So we have seen piezometer, then we have seen YouTube manometers. In the YouTube manometers, in the same level for measuring the gauge pressure, in the different level for measuring the vacuum pressure. So I hope you are understanding this concept, pressure measurement by using manometers.